Welcome to Across the Globe. Today we will learn about concurrency in Go. Concurrency in Go enables the execution of multiple computations concurrently within a single program. Go achieves this through Goroutines and channels. Goroutines are lightweight threads managed by the Go runtime, making it simple to create and manage concurrent tasks efficiently. For instance, a web server built in Go can handle multiple incoming requests concurrently by utilizing Goroutines to process each request independently, resulting in improved scalability and performance. Goroutines in Go are functions that can run concurrently with other functions, allowing for asynchronous execution. In the provided example, the fmt.println hello world function is executed concurrently as a Goroutine alongside the subsequent fmt.println welcome to Go concurrency function in the main function. This enables both statements to potentially run simultaneously, enhancing the efficiency of the program by leveraging parallelism. Subsequently, Goroutines facilitate improved performance and responsiveness in Go applications by enabling concurrent execution of tasks. Channels in Go are utilized for Goroutines communication and synchronization. They enable data exchange between Goroutines through a send and receive approach. In the provided example, a channel C of type int is created using the make function. A Goroutine sends the value 42 to the channel using the at operator, while another Goroutine receives this data using C and stores it in result for printing. This mechanism ensures a controlled flow of data between Goroutines, enhancing concurrency management in programs. Concurrency in Go is like a chef cooking multiple dishes at the same time in a busy restaurant kitchen. Each dish represents a separate task or process that the chef needs to attend to. The chef efficiently switches between tasks, ensuring that each dish is cooked properly and ready to be served. In a program, concurrency in Go allows multiple tasks to be executed simultaneously, improving efficiency and performance. Hey, Code Conquerors! Ready to level up? With TechLearn ATG, showcase your skills with official course certificates. Just visit our site and start. Need that extra boost? Get tailored learning 24/7 support and expert guidance. Coding smarter, growing faster, and making learning fun. Go to our website across the globe, www.atg.world. Concurrency in Go allows for parallelism and efficient handling of multiple tasks simultaneously. In this code snippet, a cook dish function is defined to simulate the cooking process of a dish by printing that the dish is being cooked, then pausing for a specified amount of time to simulate cooking time, and finally indicating that the dish is ready. The main function initializes a list of dishes and uses a for loop to launch a Goroutine for each dish concurrently using the Go keyword. This enables multiple dishes to be cooked simultaneously, taking advantage of the processing power available. After starting all the Goroutines for cooking dishes, the main program waits for a specified duration using time.sleep to allow all dishes to be cooked. Once all dishes are ready, a message is printed indicating that all dishes are ready to be served. Concurrency in Go is particularly useful in scenarios where multiple tasks can be executed independently and concurrently, such as cooking multiple dishes in a kitchen, processing multiple requests in a web server, or handling multiple sensor inputs in an IoT application. By leveraging Goroutines and channels, Go provides a powerful mechanism for writing concurrent programs efficiently and effectively. Concurrency in Go can be applied in various industrial settings. One example is in web servers. When handling multiple incoming requests from clients, a web server can utilize Go's concurrency features to process these requests concurrently, improving the server's responsiveness and scalability. Another example is in data processing pipelines. In a data-intensive application, multiple stages of data processing may need to be executed concurrently to optimize throughput. Go's Goroutines can be used to run these stages concurrently, allowing for efficient processing of large volumes of data. Across the globe, Go's concurrency features have been instrumental in developing high-performance and reliable systems in industries such as fintech, e-commerce, and telecommunications. By leveraging Go's concurrency primitives, developers can build systems that are capable of handling complex workloads efficiently and reliably, ultimately improving user experiences and driving business success. Keep learning, stay curious, and I'll catch you in the next video.